Hi, my name is Toля, and I'll show you how to construct the glasses try-on effect in the Banuba effect constructor. For this, we need a model of glasses which you can design in any 3D editor. I import my model of glasses, which I created in my 3D editor. To make sure the glasses will position correctly on the face, we need to configure the working units of the 3D package in centimeters. We also need a head model. You can download it from the documentation. In the Effect Construction section, Getting Started Workflow. Here you can also watch the Getting Started video with the effect construction and download the head model for proper effect positioning. We import the head model and need to scale the glasses. Before exporting a model, make sure to reset its transformations. In Maya, you can use utility freeze transformations. If you use 3ds Max, use the Reset Transform utility. Here how it works. Let's say we position the model on the head, and it has scale not equal to 1. After applying the freeze transformation command, the scale of the model becomes 1, which prevents the artifacts on the surface of the model. All real objects cast shadows, so virtual glasses are not exception. You can see my glasses also cast a shadow. For shadowing I use separate geometry. You may notice it's symmetrical with one part mirroring another, which allows me to optimize UV coordinates. We also need a cutoff geometry, which will overlap the part of the glasses that goes behind when returning the head. The cutoff geometry copies the model of the head, but has a fewer polygons. This is all geometry we need in the effect. The material name for cutting off geometry is mat_cut. For lenses, we have a separate material, mat_lens, so we could later assign a separate shader to this geometry. The mat_frame material is assigned to the frame, and the mat_shadow material is for the shadow. Now we are ready to export the geometry. For this we created the effect folder and another one inside, it's called SRC, where we place the source files. We export the geometry of glasses and shadows to the glasses.fbx file in the SRC folder. You can use the default settings for the export. I just turn off the animation because this effect doesn't have it. We also export the cutting off geometry. We could save it in one file together with glasses, or you can save them as separate files. Now we need the textures. I made them in the Substance Painter application. This is what transparency looks like. We see that the shadow from the glasses on the face for the matte shadow material is saved as opacity. For export I use my configuration, created on the basis of the built-in PBR Metal Rough configuration. I deleted all unused textures except for base color, roughness, metallic, normal, and emissive texture, which we need in some effects. Here you also need to change the normal texture settings. From the converted map section you need to drag normal OpenGL instead of normal DirectX. I found that the optimal resolution for the glasses is 256 pixels square, and for the shadows is 128 pixels square. We export textures to the SRC folder so that the effect constructor converted them to KTX format. You can read more about the benefit of this format in the documentation. Now we are ready to open our effect in the effect constructor. We see it picked up all the textures in the SRC folder. For realistic rendering of the objects in the scene, we need an HDRI texture. We will use it for image-based lighting. Refresh the effect constructor and the HDRI texture appears in the Textures tab. Click Construct and the textures in KTX format appear in the Effect folder. Now we set up the draw order of the material in the Rendering tab. I found that the effect works best if we place the matte lens material at the very bottom. Then comes matte shadow, then matte frame, and the cut-off material on the top. Now we set up the mat_cut material. Select it and specify the cut settings. Next we set up the mat_frame material. In the blend option choose alpha, because the frames use transparency. For base color we select the corresponding KTX texture. We select the HDR option since we use image-based lighting. Then we select the normal texture. Metallic and roughness texture were combined by the effect constructor into one MRAO texture. So select this option and use the corresponding texture. After that, we set up the matte_lens material. It has the same settings as frames, so we repeat previous steps: transparency, base color, HDRI, normal, and MRAO texture. Finally, we set up matte_shadow. Select alpha in the blend value and point the base color texture. Click Construct and drag the folder with the effect into the viewer window. We can stop here, but I'll show you how you can use a custom shader and achieve better reflection in lenses. For this, we will use the PNG texture. Copy it to the Effect folder, and the prepared shaders for shadows and lenses to the same folder. To enable our shaders, we need to edit the sfg.toml file, which contains the material settings. In the matte_shadow block, we remove the textures that the new shader won't use, and edit the line where we write the name of the new fragment shader. In the same way, we replace the name of the shader in the matte_lens block with the one we saved in the Effect folder. In the matte_lens material setup, we need to create the text_refill parameter that uses the new shader and point to the reflection texture, reflection.png. Save the changes and drag the Effect folder into the viewer window. You can see now the reflection improved. To clean the Effect folder, we delete unused files like the default textures, old shaders, the cubemap env.ktx file created by a constructor, and also the ktx glasses_shadow texture files that are not needed. And finally, I want to share another life hack. For lenses to have beautiful reflections, its geometry must have the correct normals, like a convex surface. I make such normals in the Houdini package by transferring the normals from a compressed sphere to the lens geometry. You can make it in any other application by compressing the sphere by one of the axes and cutting out the lens geometry from it, or use transfer attributes. Create amazing effects and have a fun!